In this previous section, we have discussed some problem based on Laplace transform. We discussed the Laplace transform sine omega t, cos omega t, and hyperbolic function of sine t and sine omega t and cos h omega t. Okay, today's lecture is based on the inverse Laplace transform. Okay, now let's begin. As the if the Fourier transform of this xt is nothing but x omega, it is nothing but summation moving from minus infinite to infinite xt e to the power minus j omega t. And if we find the Laplace Fourier transform, inverse Fourier transform, then the reverse xt is obtained by 1 upon 2 pi integral minus omega t e to the power j omega t d omega. And we know from the Laplace transform is nothing but xx sigma summation integral from minus infinite to infinite xt e to the power minus st dt. And we know that when we put s is equal to sigma s is equal to sigma plus j omega, then we got this point. And we have also discussed the Laplace transform is nothing but the Fourier transform of xt multiplied with j omega t, sigma t. Therefore it is a Fourier transform, and it is Fourier transform of xt e to the power minus sigma omega t. Okay, then if we find inverse Fourier transform from this function, okay, from this function inverse Fourier transform, then in this inverse function we get xt, because the Fourier transform of xt become this. But here the signal is xt e to the power minus t, then the inverse Fourier transform become xt e to the power minus sigma t. Okay, and sigma plus j omega x is sigma plus j omega e to the power minus j omega t. Okay, when this sigma is moving to right, e to the power minus sigma t moving to right sided, then it become xt equal to 1 upon 2 pi minus become positive e to the power sigma t, and the same inside of the integral is the same. And when we multiply this sigma with the signal, then it becomes xt equal to 1 upon 2 pi summation moving from minus infinite to infinite x sigma plus j omega t and e to the power sigma plus j omega t d omega. Okay, now as we know that s is equal to sigma plus j omega, and when we differentiate it, then ds become j d omega, because it is real term and constant, and then differentiation is 0. Okay, then this ds can be replaced with d omega can be replaced with ds upon j divided by j. Okay, now when we move limit of the signal, then as omega tends to minus infinite, then s tends to sigma minus j omega, and omega tends to infinite, then the s tends to sigma minus j infinite. Similarly, if omega tends to plus infinite, then s tends to sigma plus j omega naught. Here the imaginary parts tend to infinite, but the real part have to put at the constant, because we know that in S plane, if sigma equal to let's suppose 2, then at this position when we draw the signal, here the imaginary part tends to infinite, negative infinite and positive infinite, and it becomes the parallel line to the imaginary axis. Therefore, our inverse Laplace transform is nothing but xt is equal to 2 pi j, and the summation moving from sigma plus j in sigma minus j infinite and sigma plus j infinite and sx e to the power st ds. As we know that this imaginary this contain the imaginary infinite line, and it is very complex to find their integral function. Therefore, in practice, we do not go with this integral of inverse Laplace transform. We follow this shortcut method, or follow the property of Laplace transform, which we have already discussed. Okay, let's suppose if in the question asking for 1 upon s, okay, then we know that it is Laplace transform of ut or minus ut minus t, and inverse Laplace transform of 1 upon st is ut when sigma is greater than 0, and then and it is minus u minus t when sigma is less than 0. Therefore, we can directly find the inverse Laplace transform with the case consider that we have ROC given, and if ROC not given, then we actually consider some ROC probability of ROC, how many possible ROC happening and their respective Laplace transform. Let's begin with some example. Okay, here the first question is find the inverse Laplace transform of 1 upon s square minus s minus 4. Okay, when we factorize it, then it become 1 upon s minus 4 and s plus 3. Our first task here is to partial fraction of this function. When we partial fraction it, it become 1 upon 7 into 1 upon s minus 4 and minus 1 upon 7 s plus 3. Okay, now it is important point. We know that as it contain s minus 4 s plus 4, or it is something like 1 upon s minus a or s plus a. Okay, and here the two possible thing, as we know that 1 upon s minus a, the Fourier transform, inverse Fourier transform of s minus a is nothing but it is a Fourier transform of e to the power minus okay, let's stop. Okay, we know that the Fourier transform of e to the power at ut is 1 upon st s minus a, and similar, if we put minus inside the ut and beginning, let's suppose e minus e to the power at ut, the same Laplace transform obtained, but only difference is that this is right sided signal and their ROC must sigma have greater than a, and for the lower case it is the same Laplace transform, but their ROC must have less than a. Okay, therefore in the both the cases, if in the first cases the if sigma value is greater than 4, the two possible case obtained here. What if the sigma is greater than 4, what if the sigma is less than 4? There are two possible. If sigma is greater than 4, then the signal must have the right sided signal, and their Laplace transform, their inverse Laplace transform become 1 upon 7 e to the power 40 ut. And if it is left sided signal, then the left sided ROC, then its signal also are left sided, and then it become minus 1 upon 7, because minus put inside the ut and for 1 for the magnitude. Okay, minus 1 upon 7 e to the power 40 u minus t. Same case this for the right side and for the left sided. For the right sided it is a positive term, for the left sided it become negative, and negative positive. Okay, when we combine this, okay, there are four possible extern when both signal is right sided. Okay, when both signal is right sided, first signal is also right sided, second signal is also right sided. Okay, then If the both signal is right sided, then the first signal ROC is sigma is greater than 4 and second ROC sigma is greater than minus 3. When we plot this minus 3 at this position, let's suppose minus 3 and the 4 at this position, 4, both signal is right sided, this type and this type, as both signal is right sided, and we know the property of ROC that signal does not contain any pole. Therefore, if the both signal are right sided, then our combined ROC should have rightmost pole. Therefore, it only contain ROC which is sigma is greater than 4. Okay, and this is Laplace inverse Laplace transform, and common ROC is sigma is greater than 4. Okay, the next possible thing, when both signal is left sided, when one signal is right sided and one signal is left sided. Okay, if this is right sided, their signal must have the inverse Laplace transform is 1 upon 7 e to the power 4t ut plus 1 upon 7 e to the power minus 3t u minus t. And when we plot this signal, the first signal represents sigma is greater than 4. Then sigma is greater than 4 means it is right sided like this. And when sigma is less than 3, it is like this. It represents sigma less than minus 3, and it represents sigma greater than 4. As there is no common ROC, therefore Laplace transform does not exist for the second case. Now for third case, if first is the left sided and second is right sided. Okay, first is left sided and second is right sided, and we find this Laplace transform, and when we plot this, okay, when we plot this, the first is right sided, first is left sided. Okay, then it represents the sigma is less than 4. It means this type, this signal, and for this signal it represents the sigma should greater than minus 3 like this. Therefore, this common ROC is possible. Therefore, Laplace transform is possible if sigma is in between the minus 3 and 4. Therefore, the common Laplace transform of this signal is this. Common Laplace transform of this signal is this, and their ROC become sigma is greater than minus 3 and less than 4. Our last topic, last possible thing, if first signal is left sided and second signal is also left sided, both signal is left sided and left sided, when we plot it, left sided minus 3, sigma is less than minus 3 and sigma is less than 4. As ROC does not contain any pole, then if the both signal is left sided, we consider leftmost, and our leftmost is sigma is less than minus 3. Then our common ROC should have sigma is less than minus 3. Therefore, this is Laplace transform, and ROC becomes this. And we combine all the ROC, then it represents like this. It is for the last case, sigma is less than 3. It is for the first case, sigma is greater than 3, and it is the third case when sigma is in between the minus 3 to less than 4. And the second case, not possible. Laplace transform cannot be determined. In this question, ROC is previously not given in the question, but the most of the case ROC is given to the question. Like this is the very important question of our discussion. It is the most important question. Okay, and it says that the find the inverse Laplace transform of this signal if ROC is given like that. Okay, there is 4 possible case. The first case we find step by step, but before the moving to the first case, our first step is to find the partial fraction of this signal. Okay, let's find. It is your task to find the inverse for partial fraction, and when we find it, it become by using partial fraction, it become 1 upon s plus 2 minus 2 upon s minus 2 1, and this is plus 1 plus 2, and our pole at this position of minus 1 1 and minus 2. Okay, and in the first question it asks for inverse Laplace transform if common ROC of all the signal is less than greater than 1. Okay, therefore in first case the common ROC is when the real term of s or the sigma is greater than 1. Then we plot it here from one side. Okay, just 1 minute. Okay, if sigma is greater than 1, what happened? This is right sided, this is also right sided, and this is also right sided signal. Okay, the inverse Fourier transform of this signal is e to the power minus t. It become also positive, minus already present, 2 et ut, and this is minus, as it become positive here, minus, it minus positive, and the common ROC from it is sigma is greater than 1. Therefore 3 pole at minus 2 minus 1 and 1, the common ROC is greater than 1. Okay, in second case, our second case is if sigma is less than minus 2, this. Okay, therefore it is a sigma s is equal to 1, s is equal to minus 2, and s is equal to minus 2 and minus 1 1 and minus 2. Just 1 minute. Yes. Okay. Okay, and when we plot it and we consider here for the s is equal to minus 1 at this position, s is equal to 1 at this position, and s is equal to 2 minus 2 at this position, and the common ROC is given is sigma is less than, sigma is less than minus 2, and it is possible only when all the ROC of every signal having left sided, then we choose leftmost of the signal, leftmost pole of the signal. Okay, therefore all the signal having ROC less left sided, therefore it is in first case sigma ROC should have sigma less than minus 1, and in second case ROC should have sigma less than 1, and in second case last case sigma should have less than minus 2. All signal is left sided, and then when we plot then find inverse Laplace transform, then we get this signal, all signal is left sided. Okay, now in the third case, okay, and the ROC given a common thing, common strip line, and it is in between minus 1 and 1. Okay, and when we consider it, okay, then it is possible when the signal which having the pole at 1, it is nothing but this, should have left sided signal. Let's clear it. It is possible when this signal which have the pole at the position sigma is less have the pole at the position sigma equal to 1, and having the ROC left sided. Okay, then one point is we get here is that their ROC middle signal have ROC sigma is less than 1, and in the left sided having 2 pole minus 1 and minus 2, this signal, then minus 1 should have right-sided, because to contain this property, and this signal is also having right-sided, and we choose in between because both the signal, this signal and this signal, both should have right-sided. Then we consider only the rightmost of the pole, and the rightmost pole is sigma is greater than -1. Therefore, this signal is right-sided, this signal is right-sided, and this signal is left-sided. Accordingly, we find the inverse Laplace transform and combine this. Okay. And at last, now we have given ROC is it is greater than -2 and less than -1. Okay. Then 1, -1 and -2. Then for starting from this signal, it is it is possible, and we skip this one if they have common ROC, means this is also left-sided, this is also left-sided, having the common ROC, which is sigma is less than -1. Means this signal and this signal, which have a pole at -1 and pole at 1, having the common ROC, which is sigma is less than 1, then it is possible to have one ROC which is sigma is less than -1. And therefore, as it is left-sided, therefore both the signal have ROC left-sided, and accordingly we get the inverse Laplace transform. But in last case, to become a strip line, then sigma should have greater than -2, means it is a right-sided signal. Therefore, their inverse Laplace transform is also right-sided signal, and it is e to the power -2 t ut. This is how we take the inverse Laplace transform. And if there is no ROC given in the question, we consider the possible cases. What should the ROC, but if there is also already some ROC is given, then according to the given ROC, we will make their Laplace transform accordingly. This is enough for today's lecture.